Hello, this short video presentation is a continuation of yesterday when we were using rules of exponents. Today we're going to combine multiple rules. First of all, let me scroll over here. A couple of things to think about is one, this is going to take up a lot of space when you do these problems, so leave yourself room. Leave yourself room. Next thing that's going to screw you up is if you don't print your assignment. Print the assignment. These problems are a pain to copy. Now for the actual math, you want to simplify numerator and denominator separately. Remember PEMDAS. Order of operations. Don't forget the order of operations. That's abbreviation for operation. And simplify completely. Simplify completely. And lastly, no negative exponents. All right, now let's do this bad boy. All right, yesterday we learned that when we took a power to a power, we multiplied the exponents. So here I have a 1, here I have a 1, here I have a 1. Down here I learned that I added the exponents when I multiplied like bases. So I have a 1, a 1, a 1, and a 1. Now, the rule when we multiply, or take power to power, is multiply. We treat the x and the 2 exactly as the same. This is 2 raised to the negative 4, 1 times negative 4, x to the negative 4, y to the negative 4. When we take and multiply like bases, we add the exponents. So I have this negative just means that my product is going to be negative. 2 to the first times 2 to the first is 2 to the second, but it's negative. X to the second and y to the sixth. Now the reason I didn't just multiply 2 times 2 is I also have bases here. And I want to treat them together. I want to keep the bases the same. Now, yesterday we learned that if we had a number raised to a negative power, it was the reciprocal. We move it down. Or if we had 1 over x to the negative 2, it was just equal to x squared. I don't want negative exponents. I actually want to get rid of them. So what I'm going to do is move things around. I'm going to move this 2 downstairs. When I move this down here, it's going to become 2 to the 4th power. The exponent changes. That's all. This 2 is still here, times 2 to the second. And I'm actually going to put the negative out here, get it out of the way. I'm then going to take this x to the negative 4th, move it down, and it becomes x to the fourth. And I also have x squared sitting here. And lastly, I'm going to take this y to the negative fourth. I'm going to move it down. It becomes y to the positive fourth. And I still have y to the sixth. I have to have something in my numerator, so I put a 1. Now, the rule says when we take a power to a power, we add the exponents. So I have 1, 2 to the 6th power, x to the 6th power, y to the 10th power, or 2 times 2 times 2 times 2, 6 times, we all know is 64. So I have 64, x to the 6th, y to the 10th. And we're done. So let's look at another one. All right, this next problem looks entertaining. Kind of looks like a mess. So let's try to clean it up. First of all, this negative 3, probably the last thing I'm going to worry about. I'm going to try to simplify everything inside first. Y to the 0 power is just 1. All right? This is just 1. 1 times negative 2 is negative 2. All right? So what I'm going to do is just cross this out. It doesn't affect the problem. Now, I have an exponent of 1. I have an exponent of 1. And when I take this to the second power, negative 2 times negative 2 becomes a positive. I'm not going to worry about that negative. So I'm going to end up with 2 squared x squared, because this is 1 times 2, 2. 1 times 2, 2. Times negative 2 x to the 4th. So I've gotten rid of this set of exponents, or parentheses, I mean. And I have negative 2, x to the negative 4, y to the 3. There's nothing that I can do right there. Y to the 3. And this is all raised to the negative 3. Now I want to clean up this. Well, first of all, I notice that this negative 2, and this negative 2 can cancel. One's in the numerator, one's in the denominator. I could not have canceled this one here and this one here because this one is in this set of parentheses and this one isn't. But I can cancel these two. All right? And I have an x to the second, x to the 4th. That's equal to, first of all, I'm going to write it as 4 now. That's equal to x to the 6th over x to the negative 4, y to the 3rd raised to the negative 3rd. And then, just like before, I'm going to move this up. I'm going to end up with x to the 10th. So I have 4 x to the 4th, y to, x to the 6th, all over y to the 3rd, again raised to my negative 3rd power, and then 4 x to the 10th, y to the third raised to the negative third. All I've done is simplify it, little bit at a time, little bit at a time. Now, my exponent here is a 1. Power to a power, I multiply the exponents. 4 to the negative third, x to the negative 30, y to the negative 9. Man, did I screw that up? Y to the negative 9. Now, if I move the 4 down, it becomes positive exponent. X down, it becomes positive. Y up, it becomes positive. So I end up with y to the 9th, 4 to the 3rd, and x to the 30th. And 4 to the 3rd is just 64. So I have y to the 9th over 64 x to the 30th. And I'm done. I did a little bit at a time. First of all, I raised my power to a power, got rid of the 0. Then I combined my numerator and denominator, simplifying it, x squared, x to the 4th, canceled my negative 2's. Next step, I moved this up to make the exponent positive, just easier to deal with. Got x to the 10th. I've cleaned up everything inside, so now I do my last power to a power, power to a power, power to a power, and then I move things. If I have a negative exponent, I move it up or down to make the exponent positive. And I'm done. Please be neat, organized, and careful. These problems are not difficult, but they can be made almost impossible if you're not neat. All right, hope this makes sense. Have a great day, and I'll talk to you tomorrow.